video. My name is Jyotiska Biswas. I'm the founder and CEO of ThinkTrends. We specialize in end-to-end data mining and AI tools, as Catherine mentioned, especially for unstructured and structured data. We work with enterprises and agencies to help them adopt the latest AI capabilities while ensuring that the solutions are scalable and easy to use. So today we will be looking at some highly effective ways of monitoring opioid use among pregnant women and lactating mothers using our product ThinkTrends Social, designed specifically for social media use case. So let's go over the agenda. First, we will delve into the issue and look at the current state of affairs. Then we look at areas in which we can innovate and why that really matters. We will discuss our proposed solution and discuss some of the challenges. We will go a little bit over the ThinkTrends. We will go over the tool, and then we also have a demo prepared. We will briefly showcase our team, and then we'll have a Q&A. So a little bit of background, and Catherine gave us some startling statistics to start. And so let's start with the toll that this has on the American public. The rate at which overdose deaths have gone, they have gone up by 20% in just 1 year. And opioid use disorder, OUD, has risen by 4 times among pregnant women. 4 times the infants that are born with NAS, 4 times more infants were born in 2014 with NAS, which is the neonatal abstinence syndrome, as opposed to 1999. As a result, the infants are born with breathing problems and feeding problems, and really the mothers are at risk for opioid-related overdoses. The use of social media streams is really interesting. So if we look at the strategies that CDC has outlined, we look at what are their main objectives. So if we look at just at a high level, their main objective is to ensure that women get necessary information and proper treatment in time. And so to do that, we need to have better and more enhanced monitoring capabilities. And so to be able to prevent and ensure, prevent OUD the best we can, and ensure that women who are suffering from OUD get the necessary information and proper treatment, we need to have a really effective monitoring tool. And social media, as the topic of this challenge wishes to examine, is really an interesting use case. And we believe social media can play a very crucial role if used correctly. So what's our solution? We propose building an intelligent system with the ultimate goal of finding behavioral patterns of opioid use. And once we have done that, we want to effectively target at-risk users and patients, because that's the second goal. One is to be able to monitor, and we want to have the latest state-of-the-art technologies and capabilities to be able to monitor. But furthermore, it's important to be able to take actions on those on our monitoring, if possible. So to be able to effectively target the patients or users who are at risk, and to be able to reach out to them, to be able to give them useful information, where is the nearest health facility nearby that they can go to if they have some kind of problems. These are the kind of things we need to minimize, and we need to be able to take care of it effectively. And so those are our 2 main goals as outlined. And for our solution, what we want to be able to examine sort of broad social media users or specific patients who are public and active on social media. And of course, it's even better if those patients willingly work with the health professionals in where they are okay to get feedback through social feeds. And ultimately, we want to find things like, and the factors that determine at risk are things like, are they likely to relapse? Is there a history of abuse? Is there some history of addiction that we know of? And so we need to be able to capture these kind of pertinent topics and concepts from tweets. Now, there's just one big problem, and I think the previous presentation mentioned it, is that social media is mostly junk. It's mostly noise. Especially when we're looking at Twitter, there's really, most of it is There's a lot of inappropriate data. A lot of data is ad. A lot of data is just not relevant. It has no relevancy in terms of patients, users. And so it's really important to be able to identify this challenge. So we think that by identifying the right users who pose the risk of harmful side effects is the right way to approach it. And so how do we find that? And this is a challenge because social media posts are generally, like I said, unreliable. They often have false information. And when we're looking at case studies, it's really a challenge because unlike other case studies where the analyst has knowledge about the nature of the data, the structure of data, social media is not the case. The analysts really cannot predict what other people are going to post. And other important factor is that social media data is constantly changing. So since they're constantly changing, it's important to make sure that the analysis tools, the data preparation tools, and the machine learning capabilities stay updated, and they can continuously learn. And so we have seen from our experience, there have been many studies that have been conducted by health agencies to study epidemics, adverse reactions, especially from Twitter data. And most of them have really failed to reach any conclusive findings. I mean, I don't have the statistics on the number of studies with social media, but majority of them that we have seen published all had a caveat in the fact that they were not noisy. It's really hard to mine. And the real challenge is that using simple things like text keyword search or regular expression is not enough. And we need to be able to mimic the way an analyst would look at the data, and the analyst would change their needs and requirements over a period of time, and we need to make sure that the tools can keep steadily up to date with that. So that's why it's really important to have end-to-end capabilities, as we will go over. So our solution to address these challenges, we designed ThinkTrends Social to do a holistic analysis in real time, so we stay up to date by the minute. It's really important that we have those tools to be able to look at data in real time. So we have combined in ThinkTrends some of the most powerful and latest concepts in AI and machine learning. That includes deep learning, transfer learning, and we make them really easy to use alongside a very robust data mining and data analytics platform. So ThinkTrends Social is a component of this. It's a component that is specialized in capturing social media feeds. So when we look at the social media data as a noise, the proverbial analogy we like to use is the needle in the haystack problem. And so for here, it's not just a haystack. We can imagine, lots of haystacks. And we want to find some needles from those lots of haystacks. So how do we do that? And really, the way, at a high level, the way we want to explain it to our users is by explaining it in terms of a funneling system. It's a filter. At the highest level, we target social media streams by relevant keywords. And the keywords can be, for example, hashtags. They can be certain text. They can be a user that someone is following. If they have a post or someone mentions a user. There's a couple of options in which we can capture it. For example, in Reddit, we can capture subreddits. And we can get real-time streams for subreddits. So that's also built in into the platform of ThinkTrends Social. So that's how we do a very broad capture of the kind of data we want. But then the next step is we need to have the right sort of search. That includes Boolean search, includes faceted search to be able to have lots of statistical query built in. To be able to filter out sensitive materials, to filter out inappropriate materials, to be able to filter out data that is not really relevant to us. It's really important to be able to have these in a drag and drop and an easy to use interface. And the last is that you need to be able to create dashboards and metrics that are useful to the user. And this is really important. A lot of social media analytics tools that are out there don't let you really customize. It's not really a business intelligence tool. What it is that visualizations are pre-built. So they make the assumptions that the users are interested in such metrics. So for example, social media common social media analytics platform focus on branding. They focus on things like impressions, likes, reach, and influence. And they're interesting, but what if we want to look at other metrics? And that's where having the customization capability is really important. Since posts don't contain information necessarily in the way analysts can understand, it's important to look at the history of certain users' tweets. So for example, during a momentous occasion, nobody is going to post that I am taking opioids. They're going to post a picture of them celebrating with their, if they're pregnant mom, they're going to post a picture by celebrating, or have a baby shower that they will post online. So it's important to look at that information and categorize that this user is pregnant. And that's the first step. That's to be able to understand this is a mother, number one. This mother is possibly pregnant. This mother has children. And so that is the preliminary step. So, or it's not the preliminary step, but that's one of the important steps to be able to identify that. And to do that, your traditional regular expressions, search, really traditional text mining capabilities will not work. So we need to have advanced AI capabilities. This includes computer vision to look at images. This includes NLP and risk modeling. That's sort of like a time series risk modeling capability. Once we have those things, and that's the last layer, we expect to start finding the needles. And by needles, we mean target users who are at risk, who are possibly taking opioids, who have kids, who have a history of opioids. These are the kind of needles that we are relevant. And once we have found them, we can actually reach out to them. We can actually target them. We can give them relevant information. And so that's those are our really two goals. One is to be able to monitor and then be able to do outreach. So what is the value proposition? And I really wanted to focus on this because there are a lot of challenges when it comes to data mining and social media mining, and especially in the realm of data science. Building AI systems from scratch is really expensive. It requires a large team. It requires software engineers. It requires data scientists. There's a lot of data preparation time that goes into it. And really, the reality is that algorithms can always be improved. They can be changed, they can be improved, but it's really important to make sure that we have the components, the pipeline in which that users can do things end to end. That includes analysis, that includes annotation, that includes flexible AI workflow capabilities. And this is important, especially for social media, because social media data is constantly changing. And we cannot assume that the training data is always relevant. So we need to periodically train that model. We need to create different models. And so we can really utilize these things. And they're time consuming and difficult. And that's where ThinkTrends has these added capabilities. So we minimize time to get it operational because there's no coding. There's also annotation. There's a human annotation component. And similarly, the annotator also has AI annotation built in. So if we have trained a model, we can actually use that AI model to annotate your text. So that really makes the human's life easier. Now, it's kind of a chicken and egg. So if there's no models to annotate and find relevant information, then at the first step, the human has to do that. Once the human has made a baseline of annotations, then we can use that and iteratively improve the model over a period of time. And then further, you can actually take that model, clone it, and use transfer learning to build other models on top of that. And so all our AI workflow and data preparation tools are seamless, require zero knowledge of code or math, and it's a simple click and drag interface. And in addition to ease of use, time to operation, and cost, we ensure that it's the highest quality. So for our NLP, for example, we use state-of-the-art BERT, we use BioBERT, we use CliniBERT, SciBERT. These are all of the things that are actually built into the platform. And all you have to do is select which algorithm you want to use, which metrics we want to select, F1, precision, recall, accuracy, and we can compare them side by side. So a model built on, for example, bidirectional LSTMs versus state-of-the-art BERT, And then there's using BioBird, for example, which is trained to look at biologic data, which actually is not necessarily a good model for Twitter data, because Twitter data is not really relevant, even though we are looking for certain adverse reactions and safety signals. So with that said, I think we can jump into a little bit of a demo we have prepared here. Let me go to the next slide. So for example, this is a user. She makes a post, and we want to find, this is a person who is, if you can read here, let me go ahead. It says tired mama selfie, wearing makeup, and she also says dealing with nursing latch issues, weaning of opioids, and overdoing it on the laxatives. So this is a person, and she's holding a neonate. So this is the kind of information that we can tell from this, that one, she's taking opioids, she's a mother, mama means that she's a mother, and she has a baby, and we can tell just from the picture that this is most likely a neonate. So what you're looking at here is, this is our annotation tool, and we can actually annotate very precisely what we're looking at, where the people are, and take it from there. So let's go ahead and kind of take a look into how the platform works. So the first step, we want to start with creating the social media stream. And this is where we start broad. We start with the relevant keywords, and we use the OR logic to join them. So anytime certain words are mentioned, we go ahead and we capture that. So let's go ahead and then let's go ahead and play this video. So this is the ThinkTrends homepage. We can see, for example, on the left, we can add data. So the first thing we're going to do is we're going to go to the pipelines. And pipelines is where we can actually see certain social media pipelines. For example, we see opioids, pregnancy, Twitter tracking, COVID-19 epidemic, Twitter, which we had to, by the way, we had to stop because that was just an overflow of information, and we didn't want to take that. So for example, this is one pipeline for tracking opioid pregnancy. And we saw below what were the keywords we're looking at. So here are some of our social media ingester. We can join data. If it's a custom data that is unstructured, mixture of structured and unstructured, we can use an API to ingest it. And so this is really for a little bit advanced user. For the ThinkTrends social, we can actually connect directly to social streams. So here we're giving a pipeline social media stream name. So for example, if we're interested in looking at codeine and fentanyl in the way users are using it, we give it a name. So this is a name for what we're looking at, codeine and fentanyl use. We give it a description to be able to study and understand behavior of fentanyl and codeine use. And then maybe I can, then for the source, we select whether it's going to be, for example, are we going to get the data from Facebook? Are we going to get it from Reddit, Twitter? So we select Twitter for the purpose of this. And let's give it a schema. This is a name of what the social media pipeline is. It's a little bit more technical, but essentially we give it a name. We say codeine, fentanyl, let's just say Twitter. And let's go next. And here is where it gets interesting. So this is where we want to identify certain hashtags and keywords. And you can use tools like Annalisa.io, and there's a couple of public sort of like tools that are out there that are free, so you can look at top trending hashtags. But you really want to use a combination of specific keywords and broad keywords. The broad keywords will capture, for example, opioids. If there's any mention of opioids or hashtag opioids, it will capture it. But we also want to look at if it has fentanyl and codeine with it. So we went ahead and we can go ahead and we create it. And once we create it, the social media data will automatically start pulling the data in real time. So this is an example of how we can actually create the social media data. And so these are the keywords, and this is the description, and this is really the name of the media, the pipeline. So let's go to the next one. So once we have ingested the data, let me go ahead and get rid of that. What we want to do is we want to be able to, So we want to next be able to filter, search, and create dashboards that are useful with the metrics relevant to you. So let's go ahead and take a look into that. And so here we're going down. And so here you see labeling and annotation. We have a lot of really interesting labeling and annotation tools. But let's go to the dashboard. Dashboard is where we have, and this is a business intelligence dashboard. So none of these are all customizable, and with drag and drop, we created this. So for example, this is opioid and pregnancy study. So we're looking at a period of data. We're looking at relevant tweets. We're looking at what objects are found. For example, let me go back a little bit. So for example, this is an NLP component, and we'll get to this in a little bit, where we look at named entities that were found in the tweets and how we actually annotate certain things like that. Here we look at objects detected from images. This is done using computer vision. Here we can see, for example, the objects that the AI has detected. And here we can see a table of tweets that are available here. So let me go ahead and kind of play that, continue it. And so as we scroll down, we can see that every visualization here, we can drag and drop, we can resize. If we want to go into delve into the data, we can actually see the breakdown of all the data. And for example, these are the, for example, the entity class. Those are the kind of concepts we want to be able to capture from the tweets. And we will look into that as a follow-up. Another thing is really important to be able to search. So for example, we have autocomplete search features built in. So if we're looking at keywords like opioids, and let's say we want to look for tweets that include the word mama, and all we have to do is search something like that, and if we go down, we can actually see what that tweet was. So here for example, we're looking at a tweet, and actually that's what that one of the tweet was, and we can actually highlight. Now this is using really simple text search, and we'll look into how we can actually use NLP further to make it more enhanced. So let's go ahead and go into one of the dashboards, one of the visualizations here. So if we go down, oh, I'm sorry. Yeah. So one of the things we can see is we can drill through all of the opioids. So this is, for example, we can see the mood polarity. So we're calculating the sentiment based on that, and that's a form of like a scoring technique. That's a regression kind of tool that we have. And then, for example, if we want to add columns, toggle columns into it, we can easily just add columns. So if we want to look at the followers, we want to look at the number of friends that particular user have, we can easily do that. So this is, and we can edit, we can export. So this is a fully customizable, all of the visualizations that you see here, none of them were pre-made. We went ahead and we built that without, but all we have to do is just basically use the tools to create those visualizations. And so this is a geospatial one, for example. And one of the really cool things we can do is we can create geospatial layers. We can change the type of map. We can look at terrain map, topological map. If you see this, for example, this search, this actually lets you search addresses. And what's happening right now is we're going to go ahead and create an outline. This is a geographic boundary around the United States. And by doing this, we really can only limit our data that we're looking in for United States. And this is a rough draw, but that's okay. You know, we are able to capture the necessary information. And so let's go ahead and take a look into what happens next. And so let's look into how we can actually use something in computer vision. So now that we have seen that we can use various ways of search, filter, exclusive, inclusive filtering capabilities, let's take a look at how the AI workflow and computer vision, for example, is built right into the business intelligence platform. So let's take a look into that. So here, what we're going to look into are objects that have been found, and how did we actually find these things, and how do we train computer vision to look for relevant things. Now, we took the liberty and kind of, our thought process is that we want to first detect from pictures whether or not this user is a mom or if this is a young mother who's possibly lactating. And so this is useful information that we need to actually capture. So we went ahead and we actually captured some of these. So if we click on those mother, toddler, for example, we can see them. And when we enable the annotation mode, we can actually see them being detected on the screen. And so this is known as object detection in computer vision. What we see are objects that have been detected within the picture. And a more, I would say, the next level of object detection is something known as image segmentation, where we can precisely define where that person is. So object detection just draws rectangles. But that's a good place to start. And so here we can see, for example, we have detected mothers, we have detected infants, newborns, toddlers. And it's important to be able to keep this information because nobody's posting, we're not going to see the word toddler or infant necessarily in the tweet. It's going to say, I'm having a great day today. That's all it could be. But from the images, we can actually get these necessary information. We can look at different ways that we can actually tag them. We can change it. We actually have other annotation tools as well. So for example, if we need to flag the images, that is also important. The more we annotate, the more we mark up these images, the better the AI can actually learn. So by flagging it, this is known as a text classification. We're classifying whether it's a kind of a spam, whether it's inappropriate, and what are the classes of that. There's another tool which is sentiment. So we can actually assign sentiments. Is this the kind of images we want to see in the future? Notes. This is how we can actually caption the image. What are we seeing in the image? So for example, this is, a toddler laying down with her mother or on her mother. And this is the caption. And the more we feed captions to images, the more AI can actually automatically caption images. And so these are the kind of latest state-of-the-art computer vision technologies that are being worked on. And we make that available and really easy to use without actually ever lifting a finger to write any line of code. And so to do that, I think we're going to go into that next, where we want to start looking into how we can actually build the AI workflow. And so this is another image caption. I'm going to go ahead and fast forward a little bit. This is another image caption. And let's go ahead and click the AI model. So once we click, we see four things: object detection. We see image captioning, which is the kind of way you can write notes, and then automatically you can create a model that can caption images automatically. And so this is interesting. So now we're going into the AI workflow. And so now we have some options. Do we want this in CPU, GPU, or do we want to utilize both? Here's what's really interesting: transfer learning. And I don't mean transfer learning that's something Google and some institution has published. We can actually do transfer learning that we do for ourselves. So for example, if you have created a model in the past and we want to be able to build on top of it, we have that capability here. And let's take a look how we do that. So for example, we went ahead, we created a model called newborn detector. And then instead of training from scratch, we take that model and we build another model on top of it. So we can say, let's say this is mothers and newborns. I think I wrote mothers and children and her children. That can be newborns or toddlers. And so we have a few things here, a few things to customize. And so this model was already created. So we're just taking the existing model and building on top of it. But if you're building a model from scratch, there are a couple of options that we can do, but that is not shown here because it's a recorded video. And so once we built the model, we have actually went ahead and built the model, so we can show you here. So if we look at models that have been created using this visualization, we see, for example, mothers and children. That's a model that we use transfer learning to build on the newborn detector. We see the newborn detector, that was like sort of the baseline, just something to start with. So once we go to mothers and children, let's take a look into how we can evaluate the model. This is by no means the full aspect of what the product can do. There are very, very nice ways to evaluate the model. For the sake of time, we're not going to show some of those things here, but this is how the AI actually is learning. And so we can see on the right-hand side, if we actually click into some of these, we can actually see that it's 22,000 steps. So let me get my marker. And what we can see is, for example, it trained for 22,000 steps. Here, for example, the human labeler said it's a toddler, but the AI picked it up to be an infant. So sometimes, but it is learning. It is picking up interesting things, and over a period of time, it will learn. So it thinks that this is a toddler, but reality is that it's really an infant, or at least it's it's less than 1 year. Here's another interesting. So here the human labeled this as toddler, but the human did not label mother, but the AI was able to detect mother, for example. Let me go back so that way we can actually see that one a little bit more clearly.
Just a quick time check, Joe.
Yeah. So let me go to the next one. So let's go to the next one. So here we're looking at how we can use the advanced text mining and NLP. And here we're going to look at something called named entity recognition, relation extraction, and how we can actually annotate tweets, and the AI can detect these things. So now going back to this, this is a linked node analysis. And again, we have the power to make this, design this any way we choose. For this purpose, we went ahead and we are trying to model how relationships and entities are categorized and detected within text. And so that's what we can see here. We changed the mode, and now what we're looking at, for example, we're looking at opioids. All the tweets that have hashtag, or not hashtag opioids, just the word mention of opioids. And on the second level, let me go ahead and see if I can highlight here. Oh, these are our topics. These are our named entities. So for example, citation, are there substance use indication? Is it a symptom? Is it a drug class? All of those things are the kind of things we want to be able to find from tweets. So here we're looking at opioids. We can actually see, for example, substance use, and there's something called this person has high off opioids. Let's adjust that a little bit, and we can actually filter on images. So like if we look at an image, this is interesting. Let's go here. There's many ways to filter. If we hit that image, we can actually filter on that image. So, okay, there we go. So what we see here are this person has tweeted here. So there's one retweet, and then there's also a tired mama selfie. This is the one where we want to be able to capture that. And so let's look at the annotation, and this is really important. So here what we see is, for example, opioid. This is a kind of a class of drugs. Laxative is a class of drugs. Nursing latch issues. And these are the ontologies. These are the entity groups. So for example, we're looking at opioid tweets.
Joe, can you wrap it up in a couple minutes? Sorry about that.
Yeah, this is the last slide. And so with
Thank
that,
you.
yeah, let me go ahead. Let's go ahead and see how we can actually create some of the entity models here. So for example, this is where we can build different models, named entity recognition, text summarization, language extraction. All of these things are built in with the platform, and we have the workflow that is necessary to do that. So as a next step, our team, I want to kind of dedicate this slide to our team. Really, we have some of the most talented, hardworking, passionate problem solvers in our team from prestigious universities, and we take a lot of diligence and pride in offering really good solutions and solving hard problems. With that said, I'm going to go ahead and open it up to QA. If you have any questions, if you have any feedback, feel free to reach out to us, and please visit thinktrends.co to learn more.